Salam and welcome, everyone. So, today we're going to be working on the question on the screen that says when 229 joules of energy is supplied as heat at constant pressure to 3.0 mole of argon gas, the temperature of the sample increases by 2.55 kelvins. Calculate the molar heat capacities of the gas at constant pressure and constant volume. So they told us energy supplied as heat. So basically, Q here is equal to 229 joules. And this situation occurs at constant pressure to 3.0 moles. So the number of moles we've been told is 3.0 mole. And the temperature of the sample increases by um, 2.55 Kelvin. So they are telling us now that change in temperature is 2.55 kelvins. We're asked to calculate the molar heat capacities at constant pressure. So C, P, comma M. So that's the molar heat capacity at constant pressure is this. So we're asked to calculate that as well as the molar heat capacity at constant volume. So CVM is that. So basically, that's just what we're asked to do. Well, the first thing you have to remember is this. So as you can see, I have boxed the constant pressure. And since we're asked to find CPM as well as CVM, you have to be able to understand the question and break it down in your mind and also write things down so that you would not be confused. So generally, the formula for heat at constant pressure is Q sub P equals number of moles, okay, times Cp, comma M times change in temperature. So this is basically it. Now we have the heat at constant pressure, okay? We have the number of moles and we have the change in temperature. So we can rewrite the formula in terms of CPM. So molar heat capacity molar heat capacity at constant pressure equals QP, okay, heat at constant pressure divided by the number of moles times the change in temperature. So this is basically what we're now going to use to solve it. So remember, heat at constant pressure, when we look back at our question, is 229 joules, okay? The number of moles is 3.0 mole, and the change in temperature is 2.55 kelvins. So now what you have to do is for you to basically multiply and work with what you have. So what you end up with is putting this information in the calculator. We end up with 29.9346 joule per mole Kelvin. So this is the molar heat capacity at constant pressure. Now you have to go back to the question that we're given because we're told to find the molar heat capacity at constant pressure. You see that the information we're given the heat, the value for heat as 3 sig figs, and we're also given the value for number of moles as 2 sig figs. So we have to go with the lesser sig figs in chemistry. Don't forget to always put your information in number of sig figs that you are expected to do whenever you're doing science or math related problems. So you have CPM equals 30 joule per mole Kelvin. So this is basically how you solve this question. Now you may be thinking, okay, how do we solve the molar heat capacity at constant volume? Because we're given that as well. But good thing about it is that there is this formula that works for this perfectly. So this formula is just called Cp minus Cv equals Nr, where Cp is heat capacity at constant pressure. So this is heat capacity at constant pressure, right? As well as Cv is heat capacity at constant volume. So these are the two. So now you're going to be thinking, okay, they told us the molar heat capacity, not just the heat capacity. So one thing you can do is note that CPM is the same thing as the heat capacity divided by, sorry, the heat capacity for pressure divided by number of moles. And C comma Vm here is the heat capacity at constant volume divided by the number of moles. So you can literally rewrite this formula and work with this. So note that if there's heat capacity, to go from heat capacity to molar heat capacity, you have to divide by number of moles. So if you're giving heat capacity and you're trying to go to number of if you're giving heat capacity and you're trying to go to molar heat capacity, you just have to divide by number of moles. If you're giving molar heat capacity and you're trying to go to heat capacity, you're just going to multiply by the number of moles. So this is just like a simple math. So now let me erase this and continue our work. So we're now trying to go from heat capacity to molar heat capacity. So we're going to divide this by number of moles. divided by number of moles, divided by number of moles. So whatever we do on the left side of the equation, we do at the right side of the equation. So cancel out number of moles. So what we end up with is C comma Cp comma M minus Cv comma M equals R. So that's basically it. So we have 30 joules per mole Kelvin. We have the value for R to be 8.3145 joule per mole Kelvin. So basically, CVM ends up being, rewriting the formula, you have Cp comma M minus R. So this is basically the information. So yeah, we just substitute. So you have Cv comma M equals CPM. That will be 30 joules per mole Kelvin. You can do that, but let's not forget that we're doing science. We can't just say 30. We have to go back to the actual value we got before we did the three sig figs, so that when we're solving it, we get the exact value. So we actually have to use 29.9346 in this particular question. So that's how you do like science related problem. You're not going to use the approximate value to do a new to do a new calculation. You're going to use the actual value, and then whenever you're done with the new calculation, then you're going to approximate. So we're going to do it right now. So you have 29.9346 joule per mole Kelvin minus 8.3145 joule per mole Kelvin. So CV comma M is the same thing as 21.7896. So 21.7896 joule per mole Kelvin. So rewriting CV comma M, we have approximately 22 joules per mole Kelvin. So this is the answer for CVM. You can see that we solve for CPM, and we immediately could solve for CVM using this particular formula. So this is basically how you do this question. If you have any questions, put it in the comment section. If you would want to succeed and get all A's in all your STEM related courses, whether you're in middle school, high school, or college level, make sure you email me at shuhabitutoring@gmail.com. I have packages for personal tutoring as well as group tutoring. If you can afford the personal tutoring, just get yourself a friend or a bunch of your classmates, and you guys can um come together and have a session with me. If you would like to put anything in the if you would like to suggest anything, so put it that in the comment section. And if you would like to just book a session to see if we're going to be able to work together and you're going to like me to continue being your tutor, you can also ask for a session and we can work it out. So have a good rest of your day. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.